This is 12-4, inscribed angles. Take a minute and try the warm-up and hit pause, hit play when you're ready to see the answers. Here are the answers to the warm-up problems. Notice that in number 1, I had to know that this was an isosceles triangle, so therefore the base angles are congruent. And in angle 2, I knew about the exterior angle theorem, where the exterior angle is equal to the sum of the two remote interior angles. So the remote interior angles I'll highlight in red for you. Basically the one that doesn't form a linear pair. The two angles that don't form a linear pair with angle T. So before we learned about central angles come off of the center. So it might have been like that. But now we're going to be talking about inscribed angles. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So the vertex is right on the edge of the circle, and the two parts of the angle are chords. An intercepted arc consists of endpoints that lie on the sides of the inscribed angle and all the points of the circle between them. So my intercepted arc would be arc DF. Kind of closes up that angle, the inscribed angle. So that was intercepted arc. And a quarter arc subtends an angle if its endpoints lie on the sides of the angle. So what we're saying here is that angle DEF is an inscribed angle. It hits the edge, and the two segments that make up the angle are chords. DF is the intercepted arc, and arc DF subtends the angle DEF. We don't use the last one as much. Okay, the first theorem that you need to be able to apply is called the inscribed angle theorem. The measure of an inscribed angle is half the measure of its intercepted arc. So before, the central angle, when we had a central angle, so say the central angle was 90 degrees, then the intercepted arc was 90 degrees. Now we're saying that the angle, if you notice, it's much smaller compared to its arc measure. So that angle is going to be 1/2 of the arc measure. So there's a couple different scenarios there. Okay, so first example, measure of angle PRU. So PRU. I've highlighted the angle in blue for you to be able to see. And it is an inscribed angle since it's hitting the edge, and the angle segments are made up of chords. And so therefore the measure of angle PRU is equal to 1/2 of the arc that subtends it, which is going to be 118 degrees. So it's going to be 59 degrees. The measure of angle PRU is equal to 59 degrees. Okay, the measure of arc SP. Well, let's take a look at arc SP. It's right here. And it's coming off of an inscribed angle. That's 27 degrees. So that angle, the 27, is equal to 1/2 of arc SP. So divide both sides by 1/2. But when you divide by 1/2, it's really like multiplying by 2. So you should get double that. So 54 is equal to the measure of arc SP, 54 degrees. Okay, this is a corollary, so it stems from the previous theorem. If inscribed angles of a circle intercept the same arc or are subtended by the same quarter arc, then the angles are congruent. So think about this. If this arc is 60 degrees, then the angle coming off of it would be 30, since it's an inscribed angle. Well, then this angle is also 30, because it's also coming off of the same arc, and this angle is coming off of the same arc. So they're all 30 degrees. They're all congruent. An art student turns in an abstract design for his art project. Find the measure of angle DFA. First, we have to find DFA. So I'll highlight that, DFA. That's what we're looking for. And I was given this angle, which is 33 degrees. And I was also given this arc of 164, which I notice subtends this angle right here. And that would make that 82 2 degrees, 1/2 of the arc since it's an inscribed angle. So I actually just see a triangle that I'm going to focus on right now. Oops, that's not what I wanted. I'm just going to highlight this triangle in yellow. And I'm going to take that same triangle and bring it out here so that you can see what's happening. So I have this 33 right there. I have this that's 82 from the inscribed angle. So I can actually subtract those from 180. So 180 minus 82 plus 33, which is equal to 65 degrees. And I see that that forms a linear pair with my angle that I'm interested in, angle DFA. So therefore, a measure of angle DFA would be equal to 180 minus 65, which is 115 degrees. Another thing you could think about is that was an exterior angle that we were looking for, and an exterior angle is equal to the sum of the two remote interior angles, so it would be like 82 plus 33. So that exterior angle is equal to 115 degrees. So if you have a diameter involved as being the inscribed angle, then it's going to, since that's 180 degrees, the inscribed angle is going to be 90 degrees. So it says here, an inscribed angle subtends a semicircle if and only if the angle is a right angle. So we have 5a plus 20, which equals 90 degrees. 5a is equal to 70 because I subtract 20 from both sides. And divide both sides by 5, and a equals 14. So the measure of angle LJM, we actually notice that both of these angles subtend the same arc. So here's my arc. And so therefore, since they're both coming off of the same arc and they're both inscribed angles, they're going to be congruent to each other. So I can do 5b minus 7 equals 3b, subtract 3b. 2b minus 7 equals 0, add 7. 2b equals 7, so b equals 3.5 when you divide both sides by 2. And to find the measure angle LJM, we're going to plug that back in. So it's 5 times 3.5 minus 7. So that's 15 and 2.5, 17.5 minus 7. So it's equal to 10.5. And that's measure of angle LJM is equal to 10.5 degrees. Okay, our last type of problem, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So if a quadrilateral is inscribed in a circle, then opposite angles are supplementary. So 6b plus 20 plus 3b plus 25 is equal to 180. Combine like terms, I have 9b plus 45 equals 180. Subtract 45 from both sides. 9b is equal to 135. Divide both sides by 9. b equals, 9 goes into 13 one time with 4 left over, 45. 9 goes into 45 5 times. So b is 15. And then we can plug that in so we can find every angle. So the measure of angle G is going to be equal to 3 times 15 plus 25, which is 70 degrees. The measure of angle J we know is going to be 110 degrees because those opposite angles are supplementary. So I could just do 180 minus 7 since that's the case. Okay, the measure of angle K is equal to 10 times 15 minus 69, which is 81 degrees. and the measure of angle H would be supplementary to that. So it would be 180 minus 81 degrees, which is 99 degrees.